when sizing overcurrent protection devices for conductors rated over 800 amps, National Electrical Code Section 240.4c applies. Footnote 1 of Table 450.3 is intended to provide guidance on the application of the table for selecting overcurrent protection devices for conductors rated 1 to 800 amps. However, 240.4c specifically addresses the sizing of overcurrent protection devices for conductors rated over 800 amps. Therefore, 240.4c takes precedence over footnote 1 of Table 450.3 when sizing overcurrent protection devices for conductors rated over 800 amps. In more detail, NEC 240.4c provides specific requirements for overcurrent protection of conductors rated over 800 amps, stating that the allowable ampacity of the conductor shall be equal to or greater than the rating of the overcurrent protection device. This means that for conductors rated over 800 amps, the overcurrent protection device cannot be larger than the conductor's ampacity. Now, let's consider why 240.4c takes precedence. The NEC often contains provisions that address situations where multiple rules might seem applicable. The general principle is that the more specific rule applies over the more general rule. In this case, 240.4c is more specific because it directly addresses conductors rated over 800 amps, while footnote 1 of Table 450.3 is more general, providing guidance for a broader range of conductor sizes up to 800 amps. To further illustrate, consider a scenario where you have a conductor rated for 1000 amps. According to 240.4c, the overcurrent protection device cannot exceed 1000 amps. If you were to rely solely on footnote 1 of Table 450.3 without considering 240.4c, you might incorrectly select a larger overcurrent protection device, potentially leading to overheating or damage to the conductor during an overcurrent event. The NEC prioritizes safety and protection of electrical systems. By enforcing the more stringent and specific rule of 240.4c for conductors rated over 800 amps, the code ensures that these larger conductors are adequately protected against overcurrents. This is crucial for preventing fires, equipment damage, and other hazards associated with electrical faults. In summary, when dealing with conductors rated over 800 amps, always refer to 240.4c for overcurrent protection requirements. It provides the most specific and applicable guidance in these situations, superseding any general interpretations from footnote 1 of Table 450.3a. Always consult the latest edition of the NEC and seek guidance from qualified electrical professionals to ensure compliance and safety. We remember that electrical codes and standards can be complex and are subject to change. Staying informed about the latest requirements is essential for anyone working with electrical systems. It is crucial to remember that using an improper overcurrent protection device can lead to fire, injury, or death. Electrical work must always be done by a qualified professional. Also, make sure that you have the proper permitting and inspections done. Remember, when there is a more specific requirement in the NEC, it will take precedence over a general one. This is important to keep in mind as you read the NEC. In addition to 240.4c, it's also important to consider other relevant sections of the NEC when selecting overcurrent protection for conductors rated over 800 amps. These may include, but are not limited to, Article 310, which covers conductor ampacity, and Article 240, which provides general requirements for overcurrent protection. Understanding the interaction between these different sections is crucial for ensuring a safe and code-compliant installation. Furthermore, it's important to note that the NEC is not a design manual. It provides minimum requirements for electrical safety, but it's ultimately the responsibility of the designer or installer to ensure that the electrical system is properly designed and installed to meet the specific needs of the application. This may involve exceeding the minimum requirements of the NEC in certain situations. For example, if the electrical system is subject to frequent overloads or surges, it may be necessary to select overcurrent protection devices with higher interrupting ratings or to use surge protective devices to protect sensitive equipment. Staying up to date on the latest industry best practices and technological advancements is also crucial for ensuring the safety and reliability of electrical systems. This may involve attending training courses, reading industry publications, and consulting with experienced electrical professionals. The National Electrical Code is a comprehensive document that covers a wide range of electrical topics. It is important to have a thorough understanding of the code in order to design and install safe and compliant electrical systems. In addition to the NEC, there may also be local codes and regulations that apply to electrical installations. It is important to be aware of these local requirements and to ensure that all electrical work is performed in accordance with them. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following safe work practices. If you are not qualified to perform electrical work, it is important to hire a qualified electrician to do the job. Attempting to perform electrical work without the proper training and experience can be dangerous and could result in serious injury or death. The NEC is a living document that is constantly being updated and revised to reflect changes in technology and industry practices. It is important to stay informed about the latest changes to the NEC in order to ensure that your electrical work is compliant with the current code requirements. There are a number of resources available to help you stay up to date on the latest changes to the NEC, including online training courses, industry publications, and seminars. The NEC is an essential tool for electrical professionals, and it is important to have a thorough understanding of the code in order to design and install safe and compliant electrical systems. Remember to always prioritize safety when working with electricity, and never hesitate to seek help from a qualified electrician if you are unsure about any aspect of electrical work. Additionally, it's worth emphasizing the importance of proper documentation in electrical installations. Accurate and up-to-date documentation, including wiring diagrams, panel schedules, and equipment specifications, is essential for troubleshooting, maintenance, and future modifications to the electrical system. This documentation should be readily accessible and clearly labeled to facilitate efficient and safe operation of the system. In the context of overcurrent protection, the documentation should clearly indicate the ampacity of the conductors, the rating of the overcurrent protection devices, and the calculations used to determine these values. This information is crucial for verifying that the system is properly protected and for identifying potential problems. Furthermore, it is important to regularly inspect and maintain electrical systems to ensure that they are operating safely and efficiently. This includes checking for loose connections, damaged insulation, and other signs of wear and tear. Overcurrent protection devices should also be periodically tested to verify that they are functioning properly. Any problems that are identified during these inspections should be promptly addressed to prevent potential hazards. The NEC also addresses the issue of selective coordination of overcurrent protection devices. Selective coordination means that in the event of a fault, only the overcurrent protection device closest to the fault should trip, leaving the rest of the system unaffected. This is important for maintaining power to critical loads and for preventing unnecessary outages. Achieving selective coordination requires careful selection and coordination of overcurrent protection devices, taking into account their time current characteristics and interrupting ratings. The NEC provides guidance on how to achieve selective coordination, and it is important to follow these guidelines to ensure a reliable and safe electrical system. Moreover, the NEC addresses the use of different types of overcurrent protection devices, such as fuses and circuit breakers. Each type of device has its own advantages and disadvantages, and it is important to select the appropriate type of device for the specific application. Fuses, for example, are generally more current limiting than circuit breakers, which means that they can interrupt fault currents more quickly and effectively. However, circuit breakers can be reset after they trip, while fuses must be replaced. The NEC provides guidance on the selection and application of different types of overcurrent protection devices, and it is important to follow these guidelines to ensure proper protection of the electrical system. In addition to the technical aspects of overcurrent protection, it is also important to consider the human factors involved. Electrical safety training is essential for all personnel who work with or around electrical equipment. This training should cover the hazards of electricity, safe work practices, and the proper use of personal protective equipment. It is also important to promote a culture of safety in the workplace, where employees are encouraged to report potential hazards and to follow safe work procedures. By addressing both the technical and human factors of electrical safety, it is possible to create a safe and reliable electrical system that protects people and property from harm. The NEC also provides requirements for the labeling of electrical equipment. Labeling is important for identifying the function of different components of the electrical system and for providing important safety information. Overcurrent protection devices, for example, should be clearly labeled with their ampacity rating and interrupting rating. This information is crucial for ensuring that the devices are properly applied and for preventing potential hazards. The NEC also requires that electrical panels be labeled with the names of the circuits that they serve. This helps to prevent confusion and makes it easier to locate and energize circuits for maintenance or repair. Proper labeling is an essential part of a safe and well-maintained electrical system. Furthermore, it's essential to understand the concept of available fault current. Available fault current is the amount of current that a circuit can deliver during a short circuit condition. It is important to know the available fault current in order to select overcurrent protection devices with adequate interrupting ratings. The interrupting rating of an overcurrent protection device must be greater than the available fault current at its location. If the interrupting rating is too low, the device may fail to interrupt the fault current, which could result in a fire or explosion. The NEC provides guidance on how to calculate available fault current and how to select overcurrent protection devices with adequate interrupting ratings. It is important to follow these guidelines to ensure a safe and reliable electrical system. Lastly, the NEC is not intended to be a substitute for engineering judgment. The code provides minimum requirements for electrical safety, but it is ultimately the responsibility of the designer or installer to ensure that the electrical system is properly designed and installed to meet the specific needs of the application. This may involve exceeding the minimum requirements of the NEC in certain situations or consulting with experienced electrical professionals to address complex design challenges. The NEC is a valuable tool for electrical professionals, but it should be used in conjunction with sound engineering judgment and a thorough understanding of electrical principles.